Why does food gain or lose moisture? Why does a crispy biscuit turn soggy when left open in a room? This is due to water absorption from air. Why does a table dead fruit transform hard when left open in a room? This is due to desorption of moisture from the dead fruit to the surrounding air. Therefore, we need to understand the moisture absorption isotherm. Consider a solid surface inside a closed jar with humid water vapor. Water vapor molecules in the surrounding air can stick on the surface or soak inside a porous surface, commonly at high relative humidity. Moisture sticking is considered as adsorption and moisture soaking is considered as absorption, while moisture releasing is considered as desorption. It reaches an equilibrium when adsorption and desorption rate are same. Therefore, moisture absorption is a process of sticking or soaking moisture on a material surface, that is adsorption, and releasing moisture to the surrounding environment, that is desorption. In this video, I am going to explain the basic understanding of moisture absorption isotherms. It explains how foods interact with water in air, and this single concept determines crispness, shelf life, texture, microbial stability, drying, storage, and even packaging. I have also included quiz questions so that you could assess your understanding on this topic. Please watch this video until the end and subscribe to our channel if you like this video. A moisture absorption isotherm is a graphical representation showing the equilibrium relationship between water activity of a sample or relative humidity of air surrounding and the moisture content of a sample at a specific temperature. I am showing a typical moisture absorption isotherm of a food. Y-axis is the moisture content as gram per gram dry solids, and x-axis is the water activity of a food or relative humidity of the surrounding air. In 1918, Erwin Langmuir first introduced that solid surface has a fixed number of equivalent absorption active sites, and adsorbed molecules can form a single layer, that is monolayer. This was the first theoretical foundation of Sorption Isotherm. We can consider a solid surface with fixed active polar sites to adsorb water molecules. He considered that when all sites are occupied by water molecules, then it would not be possible to adsorb any more water molecules. We could observe the process on the surface. This was his core hypothesis. Langmuir Isotherm, which explained in earlier slide how gases that like water vapor form a single layer of molecules, that is a monolayer on a solid surface. The Langmuir Isotherm model is expressed as Me equal to mmKAW divided by 1 plus KAW, where Me is the equilibrium moisture content, dry basis, that is gram water per gram dry solids. Is the monolayer moisture content, representing the maximum amount of water that can cover the surface in a single layer, that is dry basis, gram water per gram dry solids. K is the Langmuir adsorption constant or affinity constant, which reflects the energy of binding between the water molecules and the surface. And AW is the water activity varied from 0 to 1. Langmuir Isotherm model provided the first theoretical explanation for adsorption phenomena and laid the foundation for groundwork for modern surface chemistry. We can observe the graphical representation of Langmuir Isotherm in this graph. Moisture initially increases and then reaches at a constant value when all active sites are filled. The Langmuir model is based on 6 core assumptions. Fixed localized absorption sites, that is, the surface of the solid contains a specific finite number of localized active sites where gas molecules can bind. Site capacity, that is, each active site can hold a maximum of only one molecule or atoms. Surface homogeneity and equivalent sites, that is, surface is energetically uniform, indicating all vacant sites contain similar affinity for the adsorbate. No lateral limitations, that is, no interactions between adjacent adsorbed molecules exist. That is, ability of a molecule to bind to a specific site is completely independent of whether neighboring sites are occupied. Monolayer adsorption, that is, adsorption process is limited to a single layer. That is, once all available sites are occupied, then no further adsorption can occur on top of them. Dynamic equilibrium. The process is also completely reversible via a dynamic equilibrium between adsorption and desorption process. Langmuir model works good for monolayer adsorption, that is, low water activities, AW less than 0.6. It fails at higher water activities where materials can form multimolecular layers or undergo bulk absorption. I would like to thank you for watching this video until the end. Please subscribe to our channel if you like this video.